That's right. So hey, your graphs. When you graph these three, our first one looks something like that. Here, I'll blow off a little bit. Second one should look like that. And third one, look at that. Now, why do you think all these graphs look so weird? Right? They're not straight lines. Like some of them are curves, but they stop or they don't go places.
They just don't.
Like look at the first one.
Let's just leave it.
Look at the first one. It never goes past the x-axis. It never goes down where? It never goes where y is negative. Why is that?
Because you can't have a negative square.
Because you can't have a negative square root. Right? When you take the square root of something, you can't get a negative number. Right? We can get imaginary numbers, but we don't graph imaginary numbers. So, because this cannot be, x cannot be less than 3, also we get a negative under our radical, it starts at 3 and goes out. And it never goes less than 0 for our y values. What about this one over here? What about the last one? Let's look at the last one. 1 over x plus 4. What do you notice with the graph? Where doesn't it go? It looks like it's really, really close to one spot, but it never gets there with our x value. What x value is that? Negative 4. It gets really, really close to negative 4, but it never gets there. Why is that? What would happen to that equation if x equaled negative 4?
Undefined.
It'd be undefined. Right? Because we would have a denominator of 0. Can we have that? No. Right? So those are some of the things we're going to talk about in this unit in reference to domain. Like what certain things can equal, what they can't equal, things like that. Alright, so some graphs look a little weird because we have certain rules with to follow. I don't like this view. Alright, so our next unit is operations and composition of functions. We're talking a lot about different types of functions, just like f function, g function, things like that. Functions you've seen before. We're going to talk about doing like adding, subtracting, multiplying, dividing functions. We're going to talk about the domain of functions. We're talking about composition of functions, where we're taking one function and plugging it in to another function. Alright, it's only 3 days long. That's all our unit is. 3 days long, review day, test. Right? A lot of kids really struggle with this unit though. The conceptualization part of it, they really struggle with. Now, once you get it, it's like that. Right? Domain kids really struggle with. Interval notation, they really struggle with. So some of those things we're going to see today, we really need to pay attention to. Okay? Sweet. So, first things first. Operations on functions means that we're going to add, subtract, multiply, or divide functions to combine them. What that looks like is it's either going to look like f plus g of x, or it's going to be f of x plus g of x. It can be written either way. It can be f minus g of x, or f of x minus g of x, right? And those operations can be written two different ways. Now, we need to remember to do order of operations, right? Parentheses, exponents, multiplication, division, addition, subtraction. Order of operations, and simplify whenever possible. Alright? So, find the domain means, we'll talk about that here on the next slide. Domain. So, find the domain of a function. The domain is an essential part of a function. What it means is essentially all numbers that can go into a function, or all values that x can equal in our function. Right? So we're going to find that in this unit. We're going to use interval notation to show the domain of a function, but we're also going to use real number notation. Now, I'm going to tell you right now, on the test, next week, you will be required to use interval notation. Right? And we will see what each of them are like. Obviously, real number notation is a little bit easier, but you will be required to use interval notation. We do that because next year, if you're taking pre-calc, or even an FST, you're going to use interval notation, and you need to know what it is. Alright? So, interval notation is the one you're going to have to use. Okay? It's what we're going to have to use. So, if our domain is all real numbers except 2, so like if we had x minus 2 in our denominator, and we said it can't equal 2, because we can't have a denominator of 0, right? How we're going to write our domain is two separate ways. negative infinity to 2, union 2 to infinity. Right? That's what we call interval notation. It's an interval. It's telling us which values of x, or which values can x be. It's giving us all the numbers. So from negative infinity up to 2, excluding 2 because it's a parenthesis, and then from 2 to infinity, any number between there would work. That's what our interval notation tells us. Now, if we're doing it real number notation, we'd say x is in the real number set. This isn't x equals r. Right? X is in the real number set. That's what that r is. A lot of times you'll see me write it with an r with 2 tails. Right? That means the real number set. It means any number that's a real number. Okay? So x is in the real number set, but x cannot equal 2. So this is real number notation, interval notation. Patrick, which one are you going to have to use on the test?
Interval notation.
Interval notation. Good. Thank you for paying attention. So, the 2 common restrictions. Put huge stars around these 2 things. Right? 2 super important things. The first one, our denominator cannot equal 0. You told me that. Right? Our denominator cannot equal 0 because then our function is undefined. The second thing, you cannot take the square root of a negative number. Now, we've done complex numbers, we've done imaginary numbers, right? But in this unit, we cannot take the square root of a negative number because it won't be able to be graphed. Right? There's a way to graph complex numbers, but we're not getting into that. So, for this unit, 2 huge things, 2 common restrictions. Denominator cannot equal 0. Cannot take the square root of a negative number. Alright? This thing is huge too. Right here. This is what kids screw up the most. You need to find the domain of both the original function and the answer. So once we've done like an operation to our function, you need to go back and look at the original and what you end with. Right? That's what will tell you your domain. Okay? So you need to look at both of them. Alright, any questions so far? We're good? Yeah. Alright. Just to make sure everyone's got this right. I see people writing things down, so. We good to go? Okay. So let's talk about finding domain. So for our first example, f of x equals 2 over x minus 3. What's my restriction going to be for x in this case? What can x not equal?
3.
3, right? I cannot have a denominator that equals 0. So a lot of times, you'll see me write x minus 3 cannot equal 0. I'll take whatever's in my denominator, and I'll say it can't equal 0, and then solve for x, plus 3. X cannot equal 3. Right? That's my restriction. Every other number, I'm fine with x being. Every single one. Every real number. X can be except for 3. So to write my domain then, what I would do in real number notation, it's going to look like x is in the real number set. So x equals the 2-tailed r. That's a really bad one. X equals real number set, comma, x cannot equal 3. What's going to happen is you're going to put x in the real number set for real number notation every single time. No matter what the problem is, you will always have that part. It's always in the real number set. And then you're going to put a comma and you're going to list every single restriction that you have. So in this case, we only have the 1. It's only x cannot equal 3. Now, interval notation. Right? This is listing out every single number that x can be. So x can be any number from negative infinity up to 3, but it can't be 3. So I'm going to put a parenthesis there. Right? Do you guys kind of remember this when we did our, what was it, inequality unit? When we did intervals? Yeah. Right? Parentheses not including, bracket is including. Right? Then we put a u, it's a union. So we're combining these two things, 3 to positive infinity. Any number between those works. Does that kind of make sense? Yeah? Yeah. Alright. Any questions so far? Alright, there's another one on here, isn't there? The second example, f of x equals square root of x plus 5. We said, what about a radical?
Can't be negative.
Can't be negative, right? So what I would do then is I would take whatever's under my radical. In this case, x plus 5. I will set it greater than or equal to 0 to find my restriction. Because I know it can equal 0, that's fine. And it has to be greater than, it has to be a positive number. So what I do is I solve for x. Minus 5, minus 5. X has to be greater than or equal to negative 5. Okay. Oh. They did the same thing I did. So you set the inside greater than or equal to 0, and then you solve it. Right? Because we want all positive answers. 0 and all positive answers. Now, what that's going to look like. In my interval notation, my domain would be negative 5 with a bracket, because we said it could be greater than or equal to negative 5. So negative 5 with a bracket, all the way to infinity, because we want greater than negative 5. So it's going up to positive infinity, and then parentheses. And that's it. Right? There's no other numbers it can be. My real number notation, however, is going to be x is in the real number set, comma, and then put your restriction. X greater than or equal to negative 5. Does that make sense? Yes? No? Are there any questions? Hey Quinton,
Yes.
on a test, which are the two notations you have to use? Interval notation. Good. Alright. No questions. Alright, let's try some operations. First of all though, let's find the domain for all of those. All of them. Never mind, it's over here. Alright, our first one. Look up here, f of x equals 3x plus 4. Am I going to have any restrictions on that domain? Do I have a denominator, do I have a square root? No. So my domain's going to be x in the real number set, and that's it for real number notation. Right? I don't have any restrictions. For my interval notation, it'll be negative infinity to positive infinity. Because I have no numbers I have to skip over. Right? I have no spots that x cannot equal. So my interval notation is every single number, negative infinity to positive infinity. Hey, do we ever put brackets around infinities?
No.
No, right? We can never include them because they're not actually a number. G of x. Any sort of restriction? No, right? There's no denominator, there's no square root. So x in the real number set, negative infinity, positive infinity. H of x, we get x squared minus x. Any restrictions? Any denominators, any square roots in h of x? No, so same thing. Alright, k of x, I have 1 over x plus 2. I have a denominator, so I'm going to take it to my denominator. X plus 2 cannot equal 0. Minus 2, x cannot equal negative 2. So, my domain then. X is in the real number set. X cannot equal negative 2. My interval notation, however, now is going to be negative infinity to negative 2. But I'm not including it, so I use a parenthesis, right? It can't be negative 2. Then union, negative 2 to infinity. Basically what our interval notation there is doing is it's skipping negative 2. It's jumping right over it. Right, we're saying go negative infinity all the way up to negative 2, but then jump over it to positive infinity. Okay? Does that make sense? Alright, last one. f of x equals 2 plus x, square root of 2 plus x. So we have a radical, take what's underneath it. Greater than or equal to 0. And solve for x. X greater than or equal to negative 2. Right? All I did is subtract 2. So my domain. X is in the real number set. But it's greater than or equal to negative 2. Right? List your restriction. And then, what's my interval notation going to look like?
Bracket,
Bracket,
negative 2,
negative 2, comma,
infinity.
infinity, parentheses, right? Perfect, right? Negative 2, and I'm including it because it's or equal to, all the way up to infinity. Okay? Alright. Let's try some operations. The first one, I have f plus g of x. So I'm going to add the f and the g function. Well, what is f of x? Right, we get 3x plus 4 for f of x. Right? I'm taking the functions from up here, in case you're lost. So f of x plus my g of x function up here, which is x minus 1. Okay, so we're taking the functions from these 5. So what was that one? X minus 1. Alright. Well, 3x plus x gives me 4x. 4 plus negative 1 gives me 3. So 4x plus 3. That's pretty easy, right? But I need to find the domain for it. Do I have a denominator?
Nope.
Do I have a radical? No. So do I have any restrictions? No. So x is in the real number set. Negative infinity, positive infinity. Okay? Any questions? That's pretty easy. Next one is pretty easy too. Now I have subtraction. H of x. Well, if you look up top, h of x equaled x squared minus x minus g of x, which is x minus 1. Be very careful with problems like this. Our negative distributes to both of these pieces. So it's really x squared minus x plus 1. So we're subtracting a negative 1. So be careful there. So we get x squared minus 2x plus 1. Am I going to have any sort of restriction on my domain? No. So x is in the real number set. Oops, not mine. Negative infinity, positive infinity. Oh, I suck at making infinity signs today. Any questions so far? Alright. We're multiplying the next one, k of x times m of x. Well, k of x is 1 over x plus 2 times square root of 2 plus x. Right? M of x is square root of 2 plus x. Okay. How do we multiply those? Well, what if I put this one over 1? Does that help? Multiply our tops, multiply our bottoms, right? We get square root of 2 plus x over x plus 2. That's good. I can't simplify that anymore. So that's my answer in terms of doing the operation. But now I got to figure out a domain. Right? Got to figure out a domain. Well, what type of restrictions am I going to have? Stetner, what'd you say? X cannot equal negative 2. Why is that? Then our denominator would be 0. So that's one of my restrictions. Let me list it over here. X cannot equal negative 2. Am I going to have another restriction?
Yeah.
Yeah, why?
Because
Because we have a radical, right? So if I take what's under my radical, 2 plus x got to be greater than or equal to 0, we said, right? Subtract 2, subtract 2. X has to be greater than or equal to negative 2. So I have 2 restrictions. Well, hold on a second. Those kind of contradict. Right? One says x is greater than or equal to negative 2. One says it cannot equal negative 2. It is just greater than negative 2. It has to satisfy all of the restrictions. Alright? So because this one says x cannot equal negative 2, this turns into x is greater than negative 2. Alright? So we can have any number greater than negative 2, but it can't equal negative 2. Okay? So when I go to write my domain, right, domain, x is in the real number set. X is greater than -2. Hey, does everyone understand that? Does everyone get why we made it greater than -2?
Yes.
Do I get that? Okay. So what's my interval notation going to look like? Parenthesis -2, comma, infinity. Right? I'm not putting a bracket because I'm not including -2 now. Alright? Any questions? Get out of here today.
Can we skip over some?
Alright.
So we can recess.
I would like to do,
One more.
let's do one more.
Number 5.
Hold this. Let's do 5 and 6.
Okay.
5 and 6, we'll do 2 more. Okay? We'll do them quickly. We'll skip 4. That one's an easy one. 5. H divided by g of x. So I need h of x function. X squared minus x divided by x minus 1. Right? I'm going to rewrite that though. X squared minus x over x minus 1. Is there a way to simplify that? Factor an x out of your numerator. Turn this into x times x minus 1 over x minus 1. Right? So we just get x. Right? Our x minus 1's cancel. This equals x. Now I need to write a domain though. What's my domain going to be? Do I have any restrictions? Look at our original start here. Do we have a denominator? Right? That's what I was saying before when we started with domain. People forget to look back where we started. Right? We had division here. We had a denominator. X cannot equal 1 because of that. Alright, so x is in the real number set. X cannot equal 1. Negative infinity to 1. Union 1 to infinity. Alright, you can't just look at what you end up with. We had a denominator, so we know we have a restriction there. Alright? Any questions on that one? Alright, one more. F of x divided by k of x. So if I write that, f of x is 3x plus 4, right? Divided by k of x. 1 over x plus 2. Yeah, how do we divide by a fraction? Multiply by the reciprocal. So I'm going to turn this to multiplication times the reciprocal, so x plus 2. Well, I'm going to FOIL that. 3x squared plus 6x plus 4x plus 8. Right? All I do is FOIL. So 3x squared plus 10x plus 8. So that's my answer to my operation, right? I multiplied them by the reciprocal, because I divided by a fraction. Now what about domain? What do you guys say? Can't equal -2, because look at, I have a denominator back here. X cannot equal -2. Right, so we're going to get x in the real number set. Can't equal -2. So negative infinity to -2, union, -2 to infinity. Alright? Any questions on that? Mason?
Is x, like, ever gonna not be in the real number set?
We're always going to deal with x in the real number set for this unit. So for every real number notation you write, you should always have that no matter what. Okay? Sweet.
Write them both on the top.